Hi. We have recently, thought to share the market data because we are saving the data as it arrives in the same binary format, and it gets saved for the instruments we subscribe in a sequential fashion. And at the end of the day, it's a big binary file containing all the data. So it's like uh, some days back, like we have written in our data dump group that we'll be sharing the full market replay for the below instruments, covering Nifty, Bank Nifty, Fin Nifty, Mid Cap, Sensex, Bankex Index, as well as nearest future options, expiry instruments. And today itself, I've shared the latest market replay data file and the binary. It's compressed is with Z standard. So that's why the extension is ZST, and dot bin indicates the data is in binary and not in the plain text. So it's machine readable, not human readable. So you can't just extract it and consume it in a way like how we do CSV files and see through that and get the data out. To replay it, the context or the motivation behind doing this was like we'll save it and then we'll play it programmatically, and it will just read the file individually and throw it out as we consume in with any SDK. So let's suppose how we consume data from Kite API, and uh, from their ticker SDK. So what we do on tick method, it will throw the data. We'll connect to the WebSocket by giving our credential, and then as soon as the data arrives from the WebSocket, it will go to the callback on ticks, and then it will throw the data UU, and from that point onwards, you process that data. So right now, what we'll do, I have made a wrapper for it. How I'm going to you are going to consume it. So basically, what it will do, it will recreate what Zerodha WebSocket does, what Zerodha servers does. So it will create a local WebSocket server mimicking the same market data WebSocket service as Zerodha does, and we have to bypass the override the kite ticker root URL, because it will by default connect to Zerodha ws dot kite dot trade instead, or ws.zerodha.com. Instead, it will be connecting to ws localhost, and we'll be getting the data. The only thing is that when the market is open, the tick will come as soon as the tick will happen at market. Like if there is any trade happens, the ticks are getting pushed. But here we have all the data, so we'll be pushing all at once, like read every packet and just throw it out. So it will be very fast, and it will be like for a week of worth of data can be done in minutes, can be consumed in minutes, because we don't have to wait uh, for the event to occur, because all the event has already occurred and we are just throwing it out and we are just gonna consume it. So I'll showcasing you how to use this, how to get that thing set up, and how you are going to set up till on tick callback. From that point onwards, you know how to do. So as soon as the data comes on tick callback, you take the charge from there and do whatever you want to do. So I'll be just pausing here, and then I'll be resuming it. Hi, so we have resumed, and we have already uploaded the wrapper over our GitHub pages. So in the org is India Algorithmic Trading Community, and this repository is replay market data. Here the code I have already written, and I have uploaded the wheel file as well, so that one can install the wheel file. Otherwise, you can just use this git repo, and you can just pip install with git command, git repo directly, or you can use the wheel file. I mean, you can find here release wheel file, you can download and just install it. And the example how to use also I have created here. There will be two programs. One will be the replace server, which will be replaying the data. It's very short code, because all this thing is done by this module. So it once it starts, it's just wait. As soon as you subscribe, it will throw all of the data that was happening for that day. And here the example usage where we have to import kite ticker simply, and it's our replay server. What this gentleman will create, right? It will create a replay market data server for us, and the host URL is always ws localhost 8765. The dates I'm keeping here, like 1 March, 2 March, you can keep n number of dates, but you should have that date market data replay market data file, like so let's say we have 2 days data file, or 30 days, so you have to append the date in this format, like year, month, and date. uh, do ensure that it if the month and date is having single digit, so it should be prefixed by 0. So if March 03, if it is November 11. So uh, you know same goes here. So we are just appending in a sequence where we are going to check, like 1 March first, then 2nd March. So what it will do, it will read the whole market data replay file of 1st March, and it will throw you out on your on this WebSocket server. Then it will read this 2nd March file sequentially, so it can go in numbers. This given that you should have the data uh, locally available on the disk. See, so it's same, how you do on ticker. You define the callback on ticks, on connect, on close, on error, on reconnect, and the same KWS here. API key, because we are connecting to localhost, we don't need any API key, no token, only root is, we are overriding the root URL. That is, we are replacing Zerodha URL with our replace server. Then assign the callbacks and just connect. We are not keeping thread true because just we are consuming it here. You can keep thread true and do anything in main thread. Here only one difference there, in on connect you are subscribing to all the instruments that you can do. For now I'm just subscribing with my date, and it is mandatory. Like if the date will not be passed, then how the replaceable will not be knowing how what which date data you need. So I'm just asking the replace server to throw me everything it got for 1 March and 2 March, and this callback will be receiving everything. So just what I'll do, I'll just um, start replicating this locally. So first I will make on directory, make the replay m data market data. Okay, I will cd replay m data, and thereafter I use Rai for my virtual environment. It's a Rust based Python tooling, so I'll just use Rai in it. So it will initiate a virtual environment for me. I'll pin 3.12, Python 3.12. Then I will add Rai add, and then I will add like replay market data, and the URL I'm using Git. So I'll just use Git equal to, and just let me take this Git URL. So HTTPS and this, and we are going back here Git. And once we do this, it will add this, just like you are doing a pip install, I'm just adding because I'm using this Rai as a tooling for my managing my virtual environment. So just I will write Rai sync, and it will install everything in the virtual environment. It will create a virtual environment for me with Python 3.12, and then it will add this replayed market data module which I have created as a wrapper to consume the replayable market data, which is being shared on the Telegram group as a Z standard compressed binary files. So I think this is done. So now what we'll do, we'll it's created an environment. I'll just make an example folder, mkdir example, and then we'll cd into example, and just I'll uh, uh, create some or get the binary, first I have to get this binary data in this folder, because once we run from here, from this folder, the data should be available in a folder named tick data, and all this bin file should be there. So let me just copy that from here, and we'll be resuming from there. So I have got the tick data here. So we'll see with LL and see there's a folder named tick data. We'll go inside it, tick, tick data, and we'll see there are two binary files here. Tick data 2431, like 1 March and 2 March. This bin file is there, right? So one is 2.8 GB, one is 725 MB. I think 2 March was the trial one, and the full day data is 2.8 GB for all that 5 index, including USD INR and all futures and option. Sorry. So now what we'll do, we'll just go back in our example folder. This is our example folder, and now we'll open this in an editor. So what we'll do, we'll just open the editor, okay, and this is my editor. I use Z, and this is on. This is also written in Rust, and it's very good. It's snappiest. So I'm just going to use it here to demonstrate the example. So we are in example and we have this tick data here. Now we'll create our files, like we'll just see what I have used examples. So we are gonna create these two files here, example usage, or we can just copy it now here. So and then we'll copy both. So we are going to create new file, example usage.py here, and we are just going to copy the content. You can just copy paste the file itself by downloading. So this we have uh, saved it, and now we have to create the second file, which will initiate our replay server. Name is example replay server. You can rename it, and then you can run it. I'm just, for the sake of like doing this video fast, I'm just copying pasting it, and just copy the content and paste it here. So replay market data is already installed, so it will get this. And here we are instantiating that wrapper of mine. I'm keeping debug true because I want the logs, and this is the signal handler. So anytime we press Control C, everything will be closed amicably. How it have been should be stopped. It will handle that. And this is our example usage. Let me zoom in for you if it is not. I think it's better now. So this is the example replay server, and this is the example usage. I have already mentioned this. We are just importing from Kite Connect ticker, overriding the URL, keeping the dates for the dates, like 1 March. So 1 March file is here, 2 March, and the 2 March file is here. So if you are keeping a lot of dates, so ensure that this folder tick datas have that binary files available here, right? And the same assign callback, and initiate the ticker. Keep a empty API characters token. Only root equal to replace server and this guy local server. And we'll start with KWS Connect, and we'll see. Now what I will do, I will just hide this, and I will start this uh, terminal. I will start two terminal here. So starting, and it already it's activated. We will just do in the first folder what we will do in this Python, and we'll start with example replay server. So this will, okay, sorry, we are in root, we have to move in example. So what is the content here? So these are our two file, and here also we have to just see there are two files. So here we'll start the local server, example replace server, right? It will initiate the server, right? Okay, I'm gonna zoom out so that it lot of data is going to come. So now it's just waiting. So it told like WebSocket server up and running successfully at WS localhost. This and this the same thing that we have written here as well in the program, 8765 WS. This is the address on which this example usage will be listening on. So we are going to go and run that, and you will immediately see as soon as the program will start, it will throw everything it got for the day. And you have, it will be lot and lot of data. If you keep it running, it will take some time. So it depends upon how you are consuming it. So let's start it. Python example usage, because this is the guy who is using it. And the other one example replace, creating the replace server. So first you start that, and then you start example usage dot py, and see the data is being streamed. It's that fast that you cannot read it, right? Now one more thing that I have done, you can have like five strategy listening to the same data. So you can just do initiate a new terminal, and you can initiate the same guy. You can have multiple. I'm just initiating the same in a different process. So you see that the same data is being passed on to this as well, this guy as well, right? So let's see, Python we have to cd example, and if we do Python example usage, it will also get the data. So now this is also getting the data, this is also getting data. If you have n number of strategy also, it will also listen to the same replay server, and they all will get data in parallel. So this is too much data coming, right? So let's close this, and here we are seeing that already it has processed the data for 1 and 2 as well, because it's already processed first March and the second March data. And now it, because we are not able to consume that data in that fast, the frequency of consuming is lesser than what the transmission in comparison to the transmission speed. So it's already transmitted. So now we are already playing the buffer data in memory. So if your strategy is super efficient, super fast, so within 1 minute or 30 seconds, like we see, we have started at 49:38, and what it does, 49:38 to 51:55, it has already consumed the file and thrown out to the WebSocket server. But we are lagging behind because we are printing on the console. It's taking a lot of time. So instead of printing console, we can consume it, do some logics and progresses. So basically it will be done in seconds, 2 3 5 seconds, depending upon which type of software. Here we are using Python for simplicity. You can go for niche languages, C++, C sharp, any Golang, Rust, whichever do you prefer, and that will define consumption speed. Server has already done. So the same server can be used with any other programming language, because the server what is doing is throwing the data on the localhost WebSocket server. So I have you can replace this server because very simple in Python. And then the client side, your own strategy, whatever language, you just replace the WebSocket URL to this guy, WS localhost. So if that C sharp or C or Rust wrapper can listen to this, and they can get this, they will get the same data. So now what I will do, I'll just control C here, this one, and I will this see the second strategy already stopped, and the first one is already running. So let's search for date time. Let's zoom out. So this see, now it was giving me the data of 9:39:53, now 9:40 datas. So it's point in time we are referring, everything is there. It's just as it is, it was coming in live. So we'll just close this guy, and we'll just control C here as well. We closed it, and see it's already streaming 1 March data, 11:57:32, right? 1 March, 11:57:32. Like, let's go back. Let's see, scroll up, 11:57:30, 11:57:30, go up. Huh? Last trade time for that is there was no trade in that, maybe. Here also 11:57:29. So it's a lot of data, like we can't consume that fast. So this is how you are going to use it uh, as you use in live market. But in live market you have to wait for the trade to happen and the tick to arrive. Here we have already saved the whole day data, and we are just throwing it out. So suppose like we have 100 days, 365 days of tick data, and you don't have to use any back tester, any back testing library, and you can just use the same code what you have written for live strategy, and from the same code you can back test as well. right? You just only have to spin up this local example relate replay server, and you can just change in your code. Like in your code you just go and you just change the replay server, and you can back test it like for that duration. Plus it's also having the benefit of doing execution error test. Like suppose you have some made some strategy, and whatever calculation it is doing on top of the tick data receipt, if that strategy is having any mishaps, any calculation error, or any sort of error, it will be immediately cut off, because you are replaying the market. Except this HTTP request, that order request that is going to broker, everything else will be checked. Like whether your strategy or your engine is faster or not, whether it can consume this much influx of data in right time and process in right time, or what is the latency. So like this you can do it. So I think I have demonstrated the replay how you can do well. You can just install from pip and do, yeah, you can use like that start replay server and start your usage. This is demonstration usage. You can use anything, like just have to be the kite way. So like from on ticks here, the tick is coming, so and being printed on in the terminal, right? So uh, now you hear from here, this tick on top of this tick, you can do anything, right? This is how we used to do, right? So thank you guys. Like if you find anyways, thanks. Good night.